cellular communication tower transmits over 3 kilowatts of power in the form of radio waves. This is 10 times higher than the power consumption of the average British household. Where do you think happens this power? How much power do you think your phone receives? Mobile phones receive less than microwatts of power. What happens to the difference? It gets absorbed by air. This huge energy difference is scattered around us in the form of radio waste. Can radio waste be recycled? Let me first tell you about a different energy challenge. In just over 10 years, each one of us will have hundreds of smart devices around them. These devices could be absolutely anywhere. Integrated in our clothing, for example. From monitoring patients outside hospitals to helping athletes track their performance, or allowing soldiers to communicate in the battlefield. The bad news? There is not enough lithium on our planet to power them all using batteries. Doesn't this sound like one man's radio waste could be another man's battery? My name is Mahmoud, and my research comes in to help recycle radio waste using smart textiles. By smart textiles, I mean clothing with integrated electronic functionalities that converts the otherwise wasted radio waves into useful DC power. I design antennas on flexible, low-cost and lightweight materials that can be woven into fabrics. These antennas, they do not receive information. They convert the power in the high-frequency radio waves into useful DC power. Just like the power stored in your battery. You may be wondering, if it's free power, why is no one else using it? The power received by a single antenna is very low, about 1,000 times smaller than the idle power consumption of your smartphone. This makes it very difficult to recycle the energy efficiently. I tune my antennas specifically to absorb power at microwatt levels, and have achieved efficiencies approaching 90%. What is special about my approach is making use of the textile-based properties, its size. The large area of our clothing compared to the rectifying antennas allows fitting many rectifying antennas in our clothing. This improves the amount of power received. Think of radio propagation like rainfall. If you try and fill a single glass of water from rainfall, you're not making the best use of rain. But if you try and fill in 100, you get a substantial amount of water. And it's exactly the same with radio waves. The more antennas in your clothing, the more energy is recycled. My goal is through energy recycling smart textiles, we can power a connected yet green world.